Hello, everyone. Welcome to our talk on running Llamastack to create your AI applications. My name is Urvashi Mohnani. I'm a principal software engineer on the OpenShift MCO team.
And I'm Sally O'Malley. I work with emerging tech at Red Hat, principal.
So let's get started. We'll jump right into it. So what is Llamastack? I'm sure you've heard a lot about Llamastack recently in the community and at Red Hat as well. To put it in the simplest of terms, it's a framework for building and running your AI applications, and it's making it as easy as possible. It's able to connect to different model servers like Ramalama, Ollama, vLLM, and OpenAI. And we'll go a bit more in depth into all of this during our demos later on.
Yeah, it makes building AI-powered applications much easier. It provides a standard set of core building blocks for things like RAG, telemetry, agents, safety features. All of these things are in the unified API layer that is Llamastack. It also offers some prepackaged, verified distributions. So we're going to show Llamastack running with Ramalama, which is a distribution that our colleagues are currently adding. But there's a vLLM distribution. There's some embedded ones. So it's just a plug-inable framework. It's also community-driven. Right now, it's mostly Meta and Red Hat, but there are over 160 contributors. So yeah, check it out. It's MetaLlama, Llamastack in GitHub. And it just allows you to deploy anywhere, at the edge, locally, in Kubernetes, and we're going to show that in our demos.
All right, so let's take a look at what it would look like to start Llamastack locally on your computer, kind of what the developer experience is like. So to use Llamastack, you have to first have a model running and being served at an endpoint. You can see that would be that orange box there. That can be done by Ollama, Ramalama, Podman AI. Then you have to run the actual Llamastack API server that you can run in a container using Podman, and that's what will connect to your model endpoint. And once you have these two main components running, then you can have your amazing AI application talk to this Llamastack endpoint and do all the fun AI things that you want to do with it.
Yeah, right. The easier it is to set up all of that, the more, as a developer, you can just focus on your application.
Yep. Oh, I forgot I have a clicker. All right, time for some demos. So in this demo here, we're going to be using Ramalama to serve our model, and then also run Llamastack with Podman. So if you were here earlier in Dan's talk, this might be a bit of a repeat of that. But the first thing you need to do is you need to pull down the model you want to use. In this demo, we're using the Llama 3 8 billion parameters instruct model, and we're pulling it down from Hugging Face. I've already pulled it down because it's a pretty big model. It's like, I think, 5 gigabytes, if I remember correctly. And then the next thing you're going to do is you're going to do Ramalama serve. This will serve this model at an endpoint on port 8080. As this goes through, you will see right over here in the bottom part. I'm not used to using this. Yep. Where is it? Right here in the bottom part, it's pointing to 0.0.0 port 8080. So this means that when I go to this endpoint, I can see my Ramalama serving this model. That you can see the Llama CPP there. Ramalama creates a whole chat bot already for you, so you can access that on this endpoint. And I just ask it, what is the color of the sun? And we can see that it's responding back. Did you want to say something?
Nope.
OK. So under the hood, Ramalama creates a container using Podman. So when I do Podman PS here, I can see that container running. It shows you what command it ran. If you take a look at the Podman command that Ramalama runs, you can do it by using Ramalama dry run, --dry run. You will see it's like a huge command with a lot of flags, a lot of different configurations. And it's not something you want to keep doing on your own or remembering all the configurations you need to set up. So that's where the Ramalama serve does all of that for you under the hood. The next thing we're going to do here is we're going to run the Llamastack image. We're going to start that Llamastack API server. And we're going to pass in this Ramalama URL here, pointing it to the model endpoint. And we have to also give it the inference model environment variable so it knows the ID of your model that's there. So that would be the long, huge name we had for the Llama 3 model that we downloaded. And this Ramalama Llamastack image is available, and you can get it. When you go to the Ramalama stack GitHub page, you will see there we have all of these in the resources towards the end of the slides.
Yeah, it currently needs a little update. So within the next few weeks, everything we show should totally work for you. And we do have it documented to work.
Yeah, and we really wanted to show this with Ramalama because when we were testing out things with Ollama, we realized that Ollama has been kind of messing with their models a bit, that when you pull an Ollama model and try to run it with Ramalama, it doesn't work all the time. So it's something we learned recently when we were going through this, and that's not really nice.
Yeah, Ramalama just works, and it's simple. It doesn't create a service, and it's just simple, and it works.
Yeah. So now my Llamastack container is up. We can see the UVcorn is running, and it's running on 0.0.0.0 at port 8321. So what this means is that if I go to this endpoint, I will see basically the model information there. So here I'm going to the docs of that endpoint, and this shows you all the different curl commands different endpoints you can hit within that. So now we have both our model being served. We have our Llamastack API server also up and running. Let me go back quickly because it went too fast. But you can see here now we have 2 containers running with Podman about that. And now once you have all of this running and you want to get started with your AI application, what's the first thing you try to make when you have a model?
A chatbot.
Yeah, this is like the hello world of the AI land. So here I have a simple Python script that I got Gemini to generate for me really quickly. And it starts a chatbot for me in my terminal. The 2 important things here is the Llamastack server URL, which points to our Llamastack endpoint, and the model ID, which points to the name of our model. And it's a very small Python script. And for this part, I am going to run this AI application locally on my computer. I am not doing this in a container environment right now. I just do a Python client app.py, and it starts it locally for me. I print out which model it's pointing to just to get some information. And I ask it, tell me a short fun fact about computers. So at this point during my recording, my model or something was kind of hallucinating over here, so just responded with hello instead of answering the question, which is funny because when we went to the 8080 endpoint, it was literally the same model and it gave me a proper answer. But same thing with what goes the sun? A question that's out of this world.
That's the
I guess it is out of this world.
AI, they're indeterminate, so
yeah.
That's why you got to rein them in.
Yeah, so that was me running an AI application locally on my computer, but pointing to my Llamastack server that's running inside a container. But you can also run your AI application inside a container and point it to the Llamastack server that's running in a container. So everything is containerized for you. And Llamastack has this Streamlit UI application that when you run, it basically gives you a UI that showcases all the abilities of Llamastack for you in a nice way. And there is an image for it on the Red Hat ET org, so I'm just running that with Podman. I'm pointing it to the Llamastack endpoint. So here you will see it's resolving to host.containers.internal and port 8321. The reason we do this and not do 0.0.0.0 is because we need to tell Podman to talk to this port that is exposed on my host since it's running in a container. If I did 0.0.0.0 here, it would try to talk to itself in the container, and there's no model running or no Llamastack server running inside this container. So Podman understands that when we pass that in, and I'm just exposing the port 8501 so I can access the UI on that port. So very quick, my application is now on that endpoint, and we can go and refresh that over here. And we see this is the...
That's a nicer chatbot.
Yeah, it's a nicer chatbot. We'll ask it a question here, the same question. What is the color of the sun? Mind you, same model, okay, same endpoint, and here it's giving me a good answer.
In a few minutes, I'm going to demo this in a Kubernetes environment, and I actually use light mode. So.
And over here on the side, you can see it has different, you can use RAG, it has other tools, you can explore more of what all Llamastack has to offer. All right.
So Urvashi, if I don't want to have to set this up every time, like what's the best way to manage your containers locally?
Systemd.
Oh!
Unit files. So as you saw here, we had to set up a container that's serving the model, a container that's serving the Llamastack endpoint, and then a container that's running your AI application. So we had like 3 different things we needed to do. Well, 2 really, and then the third one is just your AI application. Wouldn't it be great if we could just do this with like 1 command where you don't have to do all of this over and over again? So there's this command in Podman called podman cube generate, which I definitely did not heavily contribute to, but
she did. It's hers.
But it basically, you pass it any container IDs that you have running with Podman, and it will generate a Kubernetes YAML for you. It will generate either a pod definition, a deployment definition, based on what you pass it there. And you can basically take that kube YAML and plug it into Kubernetes.
It is really cool.
So basically, this podified it for me. So if you look at this now, this is the kube YAML. You can see all these args that were passed to the Ramalama container. We'll see that we have also the Llamastack container here. All the 3 containers are now in this pod. One thing that we have to tweak here a bit is that the Llamastack container, we have to expose the 8321 pod over here. The reason that kube generate is not automatically doing this right now is because I set network equals host. When I was trying to expose the 8321 port with podman command, it was blowing up for some reason. So yeah, Ramalama, Llamastack is still a bit of work in progress. But this works, so it was just a quick addition I had to add here so that when I run it with Kubernetes or PlayKube, it will expose the port that we need to access the Llamastack endpoint at. So now let's delete all the containers we had created. We'll just use the really convenient command podman rm-af, which force deletes all the containers that I have running. And we can check that they've actually gone down, because when I go and try to hit the endpoints, you'll see it cannot be found anymore. And now with another amazing podman command called kubeplay, which is the opposite of generate,
Who's used kubeplay, podman kubeplay? If you haven't, go home and do it.
Yeah, so I passed it the YAML that got generated, and as you can see here, it created a pod, and then it created the 3 containers inside that pod. So when we do podman ps, we can see all our containers running again, and when we do podman pod ps, we see that a Ramalama pod is running with all of those containers inside it. And now when we go back to try and hit the endpoints, we can hit the Ramalama endpoint, the 8081. We can also then hit our Streamlit UI application. And let's ask it another question. I think this time I change it. I ask it, what is the color of lemons?
Urvashi, let's kick it up a notch with some Quadlets.
Yes. It's a very happy bot. It's an easy question. It was happy as a super easy question. So, all right. One more thing here now is when we do the systemd stuff, we have something called Quadlet, which you can pass it the kube YAML, and it will auto-generate the systemd service file for you, and then you can configure it such that whenever you start your machine, it will start the model server and Llamastack server for you. So all you have to do is start developing your AI application, and everything is up and running for you. Quadlet understands Kubernetes YAML files, so you don't have to go and write your own unit file defining all the container configuration in it. All you have to do is you have to have the simple file in a certain directory that is home.config container systemd, and you just point it to the kube YAML. You call this file name.kube, and you just point to the kube YAML that's inside that directory. Let me just skip this because I made some mistakes there. But yeah, and my YAML file, I have it inside this directory. So all I need to do now is reload, do systemctl daemon reload. I'm using user. I'm not doing it as root. I want everything to run as rootless. And you just have to start that service. So.
And the sad thing is that it won't work on a Mac OS, of course. So
yeah.
Urvashi has Fedora.
And that's why this demo is recorded, because we were using Sally's Mac to show all of this. And I just did this on my Fedora. So I've started that service now, and we can take a look at the status of that.
And so now when this is in place, every time you turn on your laptop, you could enable it, so it just starts up. You've got your Llamastack running every time you turn on your computer. It's pretty awesome.
Yep, and when you look at the status of the service, you can see the logs. You can see it serving at the same endpoints. And I think here I show, I show that we can go back to the Streamlit UI application, ask it the same question again, and it gives me an answer. And you can also take a look at the service file that it generated for you with systemctl cat. And over here, we can see it did all the configurations for us. We can see the command it runs, which is a kubeplay command. So we're just kind of reusing the capabilities that we have in Podman to make the developer experience easier.
If you haven't ever tried Quadlet, I bet your mind is just exploded right now watching that, because it's one of my favorite features of Podman.
Yeah, and Quadlet, you can also do like a .container and define your container specifications. I think there's a .network as well, so there's a lot in there that you can do with it. All right, so that was running.
Cool. So that's running locally.
Locally, yeah.
So if you're developing an application, that's a great way to go. The features of Llamastack don't work as well without GPUs in a bigger environment. So we want to show how you can easily transition to a Kubernetes production-like environment. And everything's pretty much the same. You might swap out your vector database. You might swap out your model. You will change out the model server. I mentioned those external distributions of Llamastack you can plug in. Ramalama, and we're going to plug in vLLM. And vLLM is a model server that's really meant for production. It's meant for distributed inference. It doesn't even run on a Mac, so or ARM. It runs on x86. So it has this feature called disaggregated prefill and decode. I'll explain a little bit about that, not too much. But it also gives you the ability to register tools and MCP servers. That might just overload your local system. So you're free to really use the features of Llamastack when you run in a Kubernetes bigger environment. Cool. Oh, and if you're running in production, you're going to want to have some monitoring. So I'm going to show off the observability features of vLLM and also Llamastack. They're super cool. Yeah, thanks.
Your video, right?
Oh, my video is next, yep.
Oh, no,
right.
yeah, this, sorry.
Oh, this. OK, yeah, so I said I wanted to say just a little bit about prefill and decode. I'm no expert, but it's a new project called LLMD. That's how I spun up vLLM. Honestly, I spun up vLLM this way because it is the easiest way to spin up vLLM. LLMD is a new community project. You can check it out. The resources are in the end slide. There's a quick start, single command. If you're connected to a Kubernetes cluster, you will get, within a few minutes, all of the above LLMD pods and all of the service monitors you need to scrape metrics. It's very cool. So what LLMD is, since I'm showing it, I'll just explain quickly. There's the inference gateway pod. That's where all of the requests come in. And then the endpoint picker pod does some scoring and smart routing and distributes the requests to either a prefill or a decode pod. Prefill and decode are the two instances of vLLM. That's the engine. And so in prefill, that's where the first part, your query, comes in. So in multi-turn applications, agentic applications, code generation, and also RAG applications where you're processing documents. This prefill part, it keeps appending on itself with those multi-turn and processing documents. It's very CPU heavy. So the vLLM is configured in prefill to meet those requirements, versus decode is the answer portion, and those have completely different requirements. In decode, each output token kind of loops over the model, and that's very memory intensive, and so you need different vLLM engine arcs for that. And that's the idea with how vLLM and LMD is meant to really optimize inference, which is model serving. All right, I think I said enough about that. So I have a demo I'm running. I'm running in a G6 12 extra large EC2 instance, and I'm running Minikube. It has 4 kind of older GPUs. I think they're pretty good, but L4s, so they're not super expensive. This machine is $5 an hour, so if you leave it running for a day, it's like over $100, so you don't want to do that. But yeah, it's got 4 GPUs. All right. And here's all the pods I have running in my Minikube. The ones that we're going to concentrate on there are those LLMD pods. We've got the same Llamastack and the same Llamastack UI that Urvashi showed. And then we also have, I need to slow down to catch up to my recording. We also have a full monitoring stack. It's got Prometheus and Grafana and Tempo for traces, and yeah, we're going to show that. I'm not good at fast forwarding, so we're just going to ride it out. It's almost there. Yeah, we're good, we're good. All right, so I have a test script, kind of like Urvashi's test script. This is really to generate some traffic for the Llamastack so that our traces and metrics and dashboards are interesting to look at. But you can see here with Llamastack, I'm using the tools feature of Llamastack, and all of this stuff that we're doing is going to be available to you in our resources at the end of the slide. So here's the light mode chatbot, yay. But look, I'm asking, when did DevConf.CZ start? Now we're going to get into some cool stuff, okay? And it says I'm unable to verify. Well, I happen to have a document that has some information about DevConf that, unfortunately, I generated with ChatGPT, so it does have some wrong information in it, but you'll be able to see that the RAG is working, and that was my point. So I uploaded the file. Hold on, I got to pause. I don't know how to create a RAG application. I really don't. But with Llamastack, it's like included. You don't have to worry about it. You set up this, you set up your run config, you add a vector database, and you're up and running with RAG. And so now that I've added the DevConf doc, I will ask that same question again.
And you will know it's not.
Are there any DevConf experts? When was DevConf, the first DevConf? Yeah? Anyone? Radek? What year? Was it 2009? Yeah, I don't think so. Well, that's what ChatGPT thinks. And then I can, ask it more questions about DevConf, anything that's in the document. It will give me back. So you can see this is going to be very useful for some business-specific use cases.
It tends to think we're still in a virtual format.
Here, there's the API providers feature that you can see everything you have configured. I have configured in here the telemetry endpoint. When you add an endpoint for an OTel collector, you get the telemetry. But, oh, what's the weather in Brno tonight? So chatbots aren't good at giving real-time information, and that's what it's telling me. But I added an API key for web search into my Llama config, and I just chose the tool web search, and now you can see it's going to go out to the web and answer my question. And again, I don't know how to add web search to AI applications. I'm using the Llamastack framework. Now, here in production, if you're running in production, you're always going to want to monitor things, and that's what vLLM also provides, is a set of metrics that are really important for MLOps and data scientists and AI engineers. So you can see they're really pretty, very complete.
Fancy dashboards.
Fancy dashboards. And I need a pause to explain this a bit. 28 minutes, we're good.
Yeah.
All right, so Llamastack has some really interesting telemetry out of the box. As soon as you spin it up, if you collect the telemetry and visualize it, it's all distributed traces. It's sort of unique. Usually, any project you start off, they're going to have metrics by default. But it's kind of rare to have this full distributed tracing setup, and it's really incredible. So check it out. So remember, I was running that script because I wanted to get Llamastack to be very busy. And you can see here, I can really trace everything that Llamastack has done, which is really important when you're using tools and you have told your AI to, hey, use this tool to do this. Sometimes LLMs will hallucinate and just give you the answer without using the tool. You really want to make sure that your LLM is using the tool that you expect. So here's how you monitor and trace all of that information. Also with RAG, you can go into the traces and view what documents it's using. It also gives you the full prompt. So if you're sort of auditing a system, you can see what your users are or the agents are doing. I think we're going to be in a world where millions of agents are going to be doing everything. Humans are just going to be on the beach sipping Mai Tais. So yeah, and then the dashboard. This isn't really specific to LLM or vLLM or Llamastack. I just think the GPU dashboard, if you're using, NVIDIA dashboard, if you're using GPUs, it's pretty pretty. It's pretty pretty. So yeah, that is running. That's everything that Urvashi ran locally, running in a production environment. You too can do it because we have all of the manifests and files. So.
And one thing I wanted to point out was the demo that I did that was running locally on my computer, I did not have any GPUs, but the one that was, her Minikube one was using in a machine that had GPUs. So I don't know if you noticed, but the response time of the chatbot and the streaming was way faster than what you saw on mine.
Ooh, since you mentioned that, I just want to add an interesting tidbit. When you're using LLMs, there's a difference in, you can ask them to answer you in streaming or not streaming. And so when not streaming, you ask a question and you wait like 5 seconds, and then you get your big response. The user experience for that is not as nice as if you enable streaming. And with that, it just, the time to first token is what affects your user experience there. And again, that's why that prefill pod is really important to be configured to be fast. And because all you need that prefill pod to do is give you that first token. And once that's done, then the rest of the response, as long as it's kind of in line with how fast a human reads, that's good. So that's a good user experience.
All right. Okay. So a bit of a sneak peek into the future. You already kind of saw it in the demos as well. Ramalama and Podman really want to put developer experience first and make this as easy for you when you're a user who doesn't know really much anything about model serving, Llamastack, AI, but you want to start creating your AI applications. It would be amazing if we could just do one command, Ramalama serve, tell it which API endpoint you wanted to create, pass in any MCP server stuff, and it creates that pod for you with the containers inside it. So that's what we're looking at, basically having one pod running a container that's serving your model, a container that's serving the Llamastack endpoint, containers serving any MCP servers that you configure, and then your AI application connecting to that. So in my demo, I showed all three, like the model server, the Llamastack server, and my AI application in the pod. But I could also just have had the model server and Llamastack server in the pod, and my AI application could be running in a separate container, and it would still be able to connect to it. So that is a possibility. And we have that documented in the tutorial that we'll share with you in the resources. So Dan, this will be coming soon. Hope you're happy.
Dan, well, we'll get to the next slide.
Yeah.
So teamwork makes dream work. Okay. Nathan and Charlie, they are the ones who have been working on making Ramalama and Llamastack work. And Eric, Curtin, and Dan, they created Ramalama. Urvashi and I, we were actually the first ones to see if all of this actually works, apparently, because yesterday we were procrastinating, and we put the whole thing together, and it did not work at all. So we sat and debugged with Dan for a few hours. Mac OS network equals host does not work, and that's the bottom line of our problem. So yeah, big shout outs to these guys. I wanted to bring cardboard cutouts for Nathan and Charlie because they actually created Ramalama Stack, but I couldn't fit those in my bag, so.
Yeah, when we started, we were like, oh, how hard can it be? Everyone says it's so easy to use, but it was a pain to debug all of that. But we have put it together nicely for you, so you can get started easily.
Yes, you can thank us.
Yeah.
And I know what you're thinking. You must have used AI to make those pretty slides, but we did not. We used Cedric and Stefan and poached their slides, as did Dan, I think.
That is what open source is about, right? Sharing.
So thank you all so much. We have our demo tutorial. Is that where so Urvashi's video? Oh, you can.
So basically, these are the steps that I ran through in my local setup. It has all the commands you need to run, the caveats with the podman stuff. This is basically the huge podman command that Ramalama serve runs for us. So here we just had to update the ports that are exposed to make it work on a Mac. And yeah, it just goes over all the setup you need. It even shows you how to podify those containers that you create till we create that one-line command for you.
And then we have a setup with Minikube. We'll just show that one. Yeah. So this is my observability stack on Minikube. Now, you're on your own to just spin up an EC2 instance and get your NVIDIA drivers and your NVIDIA container toolkit. Get those set up. Very well documented in NVIDIA docs. Reach out to me if you have trouble with that. I've done it like 50 times. But after you have that machine set up, you can follow this tutorial, and you should be up and running with everything I showed in my demo.
And we will post these slides on the schedule if we haven't already. But yep, that's all we have for you today.
We have like 1 minute for questions, or you can reach us out there.
Yes.